This is what I call the carbon capture module. In fact, it's only a single prototype fan unit of the carbon capture module, but it's a very big deal. It's a very small component in a very big vision that will remove sufficient CO2 from Earth's atmosphere to make a measurable difference. We used a couple of instruments. This is a carbon dioxide monitor, and we used some chemistry. I'm an old chemist and chemical engineer. Up in here, it's just running on water right now, so it's safe. There's a spray bar. Here we have a 5-gallon graduated bucket of a solution that will react with carbon dioxide in the atmosphere. Over there we have a gallon, 4 liters of captured carbon. And here, I am very proud to say, in this 1 liter flask, we have approximately 100 milliliters or cubic centimeters of captured carbon. This is actually CO2 that was just a day or two ago in the air, and right now it's in this flask. My name is Andrew Bailey. I'm the founder of an organization or a startup company called Sacred Earth Enterprises, and our business is the business of climate restoration. What is climate restoration? First, it's the daunting task that we must accomplish successfully if our future generations, our children, our grandchildren, are to inherit a safe, habitable Earth. Secondly, it is an urgent global initiative to restore Earth's climate to its pre-industrial state. In fact, it is possible, practical, and profitable to restore Earth's climate to its pre-industrial state. And that's what we're going to talk about in this presentation. The world's greatest problems are also the world's greatest opportunities. Climate change is no exception. As Dr. Sanjeev Kagram, Dean of the Thunderbird School of Global Management, said at Davos at the World Economic Forum in 2020, climate restoration presents a multi-trillion-dollar investment opportunity. A multi-trillion-dollar investment opportunity. Let's keep that in mind. There is an estimated 1 trillion tons of carbon that we humans have placed in Earth's atmosphere since the beginning of the Industrial Revolution. That trillion tons is accessible to us. It's free for the taking. Think about that. Think like a miner. That trillion tons can replace the concrete, steel, and aluminum industries. How's that for an investment opportunity? I am the founder of a team that has been developing a rapid response set of solutions to the climate emergency since the Paris Accord back in 2015. This instrument is a carbon dioxide monitor. As you can see, it reads 410 ppm, which means that the local air contains 410 parts per million of carbon dioxide. That's pretty much the global average right now. Let's put that into perspective. Homo sapiens has never before existed in a time when the carbon dioxide content of Earth's atmosphere was above 300 parts per million. Now we're at 410. So over the ice ages, the interglacial periods, the carbon dioxide level has gone up and down, as has global temperature, as have the sea levels. And yet, never in all that time has the CO2 level peaked above 300 parts per million. Why is this important? It's important because carbon dioxide and methane and a few other gases are greenhouse gases, which means that they accumulate in the atmosphere and they prevent the sun's heat, the infrared heat from the sun, from leaving planet Earth, from escaping through the atmosphere and harmlessly going back into space. Can we remove a sufficient quantity of CO2 from Earth's atmosphere to make a difference? That's the business we are in. Carbon dioxide removal from the atmosphere is a significant part of our operation, and we have just built and tested the very first carbon capture module which is something we'll be talking about as we go along here. So just as a reminder, 410 parts per million is a disaster. We know that. We've known that for a long time. We all know the problem, but how many of us know the solution? Is there a solution? Is there one single solution? My answer to that is no. There's a set of solutions. There are a number of things that we must do if we are to survive as a species. I am part of 3 different groups that gather weekly or twice a month, and I've learned a lot from my fellow scientists in those groups. There's a consensus. The consensus is this: we must stop burning fossil fuels. I think all of you know that. Secondly, we must start extracting what we call the legacy carbon dioxide, the trillion tons. We must make an immediate and massive start on removing that carbon dioxide from Earth's atmosphere. And finally, number 3, the third leg of the climate stool, we must begin to reflect the sun's infrared heat back into space in a safe and harmless manner. And we have strategies for that. My relevant personal training is in chemistry and chemical engineering. And this machine here, the carbon capture module, is the simplest imaginable chemical engineering system. And it runs on chemistry that I learned at the age of 14. How does it work? Carbon dioxide is acidic. It reacts with any alkaline substance to form a new compound, such as calcium carbonate, also known as limestone, or sodium bicarbonate, commonly known as baking soda. These 2 compounds do not create global warming or climate change, and they can be created using carbon dioxide from Earth's atmosphere. Why is that important? Because those compounds are useful. Calcium carbonate, limestone, can be used in concrete. It can be the aggregate, the gravel, used for concrete manufacture. Sodium bicarbonate can be turned into a number of other products. The one I'm most interested in is carbon fiber composite material for 3D printing. What does that mean? It means we literally can take the carbon in Earth's atmosphere and use it to build anything we can imagine. Cars, planes, boats, trains, buildings, cities, space stations, built from the carbon in Earth's atmosphere. This little machine, the carbon capture module, is part of a much larger system. One carbon capture module will capture a little bit of CO2 from Earth's atmosphere for every hour that it runs. We did a recent test. We ran it for a couple of days, and we captured a few grams of carbon dioxide. That was a success. Now we need to do that on a much larger scale. The carbon capture module, it's actually the one we're looking at here, is just a single fan unit of a full-scale carbon capture module, which actually contains 16 such fan units. And that is part of something we call the Sacred Earth EnviroPlex. The Sacred Earth EnviroPlex incorporates an entire array of carbon capture modules. A full-scale EnviroPlex will have 128 of these carbon capture module fan units, all running 24/7 and capturing carbon from Earth's atmosphere every minute of every day. That's our next goal, to build a prototype EnviroPlex based on this technology. Our business model calls for these systems to be mass-produced and globally deployed. Here's my idea. Go to the most polluted cities on Earth: New Delhi, Los Angeles, Mexico City, Beijing, the list goes on and on. Each group of 1 million inhabitants receives an EnviroPlex, which will provide a community center. It will provide work, food, all kinds of opportunities, and pure clean air for those who live and work within that building. The EnviroPlex captures carbon dioxide. Yes, that's true. But it also does much more. The very first thing it does is to clean the incoming air. It filters the incoming air and removes from it pollutants, particulate matter, things that cause massive health problems. which is one way of avoiding literally billions of dollars in avoidable healthcare costs. The building provides organic food, carbon-free energy, purified water, livestock feed, employment, housing, education, and job training. It's a community center. The multi-purpose pavilion can be configured according to the local community's needs.